All right, so in this video, we're going to talk about absolute value and absolute value inequalities and how to solve absolute value inequalities. So we want to start by taking a look at our word problem. So June wants to know if her little brother is getting sick, so she takes his temperature. Normal body temperature can be determined by the absolute value inequality. Absolute value of T minus 98.6 is less than or equal to 0.5, where T represents body temperature. Our job in part A is to solve the absolute value inequality and show all of our work. And part B is to determine which of the following values satisfy the absolute value inequality that we solve in part A. So, things we want to think about here. Number one is absolute value. So a lot of times this is a concept that a lot of people end up having trouble with. So if we take a look at the inequality we are given here, which is absolute value of T minus 98 is less than or equal to 0.5, and we know that T represents the body temperature. A lot of times people are thinking about those lines and they don't really understand what they mean. So these lines with anything in the middle represents absolute value. This is just a quick reminder. So this is something that we have gone over. Absolute value is distance from zero. So, quick example of this, if I have a number line and I have 0 and I have positive 1 and negative 1, they are both exactly one step away from 0. Negative 1 has to hop one step in the positive direction. Positive 1 has to hop one step in the negative direction, but we're not talking about direction, we are talking about distance, so they are both one step away from 0. So each of these guys has one step to go. One step here, one step here. That means when we write this out as symbolism, absolute value of positive 1 is 1. Absolute value of negative 1 is 1. And anytime I see these lines with stuff in between them, I'm going to read it out loud as absolute value of whatever's in the middle. So now let's jump a little bit to absolute value of X. What this tells me, so what I know about absolute value is that there are two things that can give me an absolute value of 1. Positive 1 and negative 1. So now if I try absolute value of X equals 2, one of the things I want to be thinking about is that there are two things that can give me an absolute value of 2. It could be negative 2, because when I put negative 2 inside the absolute value, that's 2 steps away from 0, or positive 2. So these are my two solutions. So the key takeaway with absolute value is that when you're starting a solution process, you need two solutions, not just one. You'll see it as one, you have to turn that into two, and that you do that by making one negative and one positive, because remember, when you put a negative into the absolute value, it is distance that you're talking about. Distance is not negative. That is why the negative becomes positive. A lot of times, people see this as the trick being you flip the signs. No, because the sign of a positive stays positive. Other times people will see, oh, you just changed the sign of a negative, but you have to understand why you do that in order to do this properly. Otherwise, you're going to end up having problems with these types of equations and inequalities down the line. So now part A is to solve this absolute value inequality. So this is a nice one. We didn't have to write our own equation. We didn't have to write our own inequality. They're giving us one. Whenever you get that, you want to be like, okay, this is a gimme. I got this. They gave me an inequality to work with. So I'm going to start by rewriting it. T minus 98.6, absolute value of T minus 98.6 is less than or equal to 0.5. Now we're going to think about our crash course that we just did and apply it. So I know that there should be two solutions. I also know that one of them needs to we need to start it out by being negative. It might not end up being the real world solution, but that's my first step. So I want to break it out of the inequality by saying that negative 0.5 is going to be on one end of this, and then I have T minus 98.6 in the middle, and 0.5 is on the other end. So now I've created a compound inequality from this absolute value inequality. And that's the big takeaway with absolute value inequalities, is that they are actually just compound inequalities. And we just take one guy, goes on the other side. We flip its sign. The constant over here, the total, we end up moving it to the other side and it changes sign. So we see we have positive, we have negative, we kept our inequalities in the middle. So now we talk about solving it. So when solving this type of compound algebraic inequality, essentially it's like we have two balance beams instead of one, and everything needs to remain stable. And we are still always going towards that goal of finding the value of our variable. So in this case, it's pretty simple because we have a subtraction, so we just need to reverse it. And that's going to zero it out in the middle here, meaning I'm going to end up with t is less than or equal to less than or equal to. So t is now solved for. Now we just have to make sure that we follow our property of equality. But in this case, instead of just bringing it to one side, I bring it to both sides. Okay, so now I want to take a look at this and say, okay, 0.5 plus 98.6, well, that's going to be 5 plus 6 is 1. They're both in the same place value, so I can add them. 1 plus 8 is 9, so 99.1. So t is going to be less than or equal to 99.1. And then, I don't know how I turned that into a 5, 98.6, not 98.5, sorry about that. Negative 0.5 plus 98.6, that's actually just subtracting, so it's 98.1. So these are our two values. 98.1 is less than or equal to t, which is less than or equal to 99.1. So now we want to talk about graphing it, because I think that in this type of an inequality, graphing it helps us really see what's going on here. So I'm going to start my number line down here, and I know what my two target numbers are. So 98.1 and 99.1, which are exactly one away from each other. So I have 98.1 and 99.1. So they're one step away from each other as far as whole number, but we can break that down into decimals. We can do whatever we want. We just have to think about place value and how they compare to each other. Now, let's talk about this solution. 98.1 is less than or equal to t, which is less than or equal to 99.1. When graphing a compound inequality, we're essentially graphing the conjunction or disjunction of two inequalities. So we're talking about whether they overlap or not. What makes it difficult here is that this first one that I've highlighted in pink is not typical to how we're actually looking at inequalities normally. Normally we think about the variable being on the left side. So if I'm going to move that variable and just look at 98.1 is less than or equal to t, t is bigger than 98.1, greater than or equal to 98.1. Our blue inequality does not need to be changed. T is less than or equal to 99.1. And you can see that I've written and. So t needs to satisfy both these things. So now we can talk about graphing it. So if I'm talking about t being greater than 98.1, I know that this is a closed circle and my graph should be going to the right. T being less than or equal to 99.1, also a closed circle, but I graph to the left because that's where less than is. So now I can see that when I have and, we're talking about a between situation most of the time. So in this case, it's between. So when we actually graph this, it's essentially a connect the dots. We have to talk about anything between being part of the solution set. So anything in the middle, 98.1 to 99.1 works. Anything outside of that doesn't work. And now we can take a look at part B, which is which of the following values actually satisfies this absolute value inequality. So essentially we're looking for any numbers that are between 98.1 and 99.1. So we just have to go through and say yes or no. 96.6 is to the left. It's lower than 98.1, doesn't work. 98.1 works. That is part of our solution set, and because this is inclusive, less than or equal to, greater than or equal to, it is part of it. The number is part of it. 99.0 is less than 99.1, so that works. 100.1 is greater than 99.1. Get out of here. 101.1 also greater than 99.1, so that's got to go. So that allows us to think about the fact that absolute value inequalities, any inequalities, those are all about solution sets as opposed to specific numbers as solutions. So we are given different possibilities, and if we bring this back to the context of the original problem, which is June trying to determine if her little brother is sick, we know which temperatures are normal. If he's at at the B or C temperature, he's fine, but 96.6, that's too low. 100.1, 101.1, those are too high. So she would she'd be able to know if he's getting sick, if his temperature is outside of this range, and if it's inside the range, he's doing okay. So that's solving an absolute value inequality.